You're watching an unexpected visitor from deep space. Meet 3I Atlas, the third interstellar object ever spotted by human beings through the Atlas program.
At 6:40 Beijing Standard Time, the room was silent when the line appeared on China's official report. Nothing about the object has changed, and yet everything has. The words landed like a verdict, measured, unemotional, but unmistakably final. Astronomers who read the translation stopped mid-breath. The phrasing was scientific, yet carried the weight of something irreversible, as if the universe had just handed down a decision. And beneath that calm surface, a deeper message took shape. If nothing about the object had changed, then something about us had.
Ground team carried out a series of rehearsals. 2 days in advance, we conducted trial shots of 3I Atlas.
China's report did not sound like standard astronomy. It sounded like a conclusion, a closing argument delivered with surgical restraint. The tone was quiet, almost clinical. But inside that restraint, experts sensed an unmistakable edge, a subtle assertion of authority. For decades, the world expected interstellar confirmation to come from NASA, ESA, or a Western consortium. Yet here, China spoke first, and their opening line, delivered without flourish, made disbelief seem almost naive, as if they were quietly saying, "You doubted, we measured." That single shift, who gets to confirm cosmic truth, unsettled astronomers worldwide. It changed the atmosphere of the discussion and set the stage for everything that followed. The story begins months earlier, far from Beijing's conference halls. On July 1st, 2025, the Atlas Survey Telescope in northern Chile detected a faint, fast-moving speck of light. At first, it resembled a routine comet, nothing unusual, nothing historic. But its path betrayed it. The object refused to bend the way comets should. Within days, orbital solutions confirmed the impossible. Its trajectory was open, hyperbolic, and unbound to the sun. 3I Atlas, the third confirmed interstellar visitor in human history. Only 3 objects have ever crossed into our solar system from another star. Oumuamua in 2017, Borisov in 2019, and Atlas in 2025. 3 cosmic messengers in all recorded in science. Interstellar objects are not neighbors. They are travelers, bodies forged in the chemical furnaces of distant suns, carrying dust signatures from worlds we may never encounter. They enter our solar system only once. No orbital repeat, no second chance. One arc through sunlight and then into the dark. This alone made 3I Atlas historic, but the universe had more in store. Its speed raised eyebrows first. Racing at nearly 209,000 kilometers per hour, it cut through the inner solar system with astonishing velocity. A foreign body in a fleeting passage, giving astronomers precious little time to understand it. Which is why what happened next felt almost unreal. Space does not wait for human schedules, but human systems always obey them. And in late September 2025, every major Western observatory paused at exactly the wrong moment. Hubble entered a gyroscope recalibration, a routine but unavoidable procedure that temporarily blinded its precision. James Webb began a scheduled instrument switch from NIRCAM to MIRI, a shift requiring over a day of thermal stabilization. The Very Large Telescope shut down for mirror cleaning, using CO₂ snow and nitrogen jets. Gemini North and South turned to pre-approved programs. Pan-STARRS and Atlas were occupied with potentially hazardous near-Earth objects. Individually, each decision made sense. Together, they created something astronomers dread, a total Western blind spot, 36 hours of silence. And at that exact moment, 3I Atlas slipped into the most revealing phase of its journey. It entered a region dangerously close to the sun's glare, a place where constant monitoring is essential. But the telescopes capable of capturing its behavior were offline. All of them. The consequences were immediate and irreversible. In those 36 hours, the West lost access to peak outgassing, chemical shifts in the coma, dust-to-gas ratios, morphological changes, potential non-gravitational accelerations, light curve continuity, and rotational signature transitions. These are not minor details. They are the core of understanding an interstellar object. A gap this large in a once-in-a-century event opened the door to a silent, unexpected pivot in global astronomy. While half the world slept, 3 remote observatories stood awake: Ali Observatory in Tibet, Qinghai Station, and Yunnan Observatory. High-altitude platforms, thin air, cold winds, cloudless skies. Their schedules did not overlap with Western maintenance cycles. Their night conditions remained stable. Their robotic scheduling software, shaped by experiences in Antarctic operations, made real-time decisions with quiet precision. As Western systems dimmed, China's network pivoted instantly. For 36 uninterrupted hours, China alone watched 3I Atlas. Their instruments captured astrometric drift with subarc-second accuracy, brightness evolution in real time, spectral behavior of CO2 outgassing, coma expansion, dust jet signatures, and thermal responses under solar pressure. During this window, Atlas moved over 1 million kilometers, and China recorded every moment. The servers under ice worked tirelessly. Machines at 4,000 meters hummed through freezing nights, powered by diesel generators and solar backups. FITS files were time-stamped to the millisecond and streamed down thin fiber links to centers in Nanjing and Beijing, accumulating hundreds of gigabytes of uninterrupted observation. Then, without ceremony or political flourish, the images appeared online. Routine uploads on the China Virtual Observatory. No press release, no announcement, no warning. Yet these quiet postings would soon ignite a global storm.
3I Atlas was discovered on July 1st by the NASA-funded Atlas survey. It was discovered using their telescope at Rio Hurtado in Chile, and it was first detected as a speck of light moving relative to background stars. We collected...
In Pasadena, Houston, and Washington, the quiet arrival of China's data struck like a cold wind. NASA had not anticipated this. Not the blackout, not the timing, and certainly not a scenario where China held the only continuous observational record of a historic interstellar object. Inside NASA's headquarters, the reaction was immediate and unmistakably embarrassing. Privately, officials admitted the timing was extremely unfortunate. Publicly, they remained silent. There were no press briefings, no acknowledgement of the missing 36 hours, and no explanation for why the world's most advanced space agency had been absent at the moment of greatest scientific significance. Behind closed doors, NASA quietly reached out in hopes of obtaining the raw Chinese FITS files, indirectly, cautiously, mindful of appearing dependent and wary of fueling geopolitical tension. But the damage was already done. For the first time in its history, NASA lacked autonomous verification. There was no overlap, no parallel confirmation, and no uninterrupted data chain. And in astronomy, a field where truth is reinforced through redundancy, such a lapse was unprecedented. This was where the narrative of a fight began, not through statements or accusations, but through silence. A silence that exposed vulnerability, imbalance, and a shifting scientific order. Because for those 36 hours, only one nation saw the sky, and that changed everything. The blackout did more than shift scientific authority. It reminded the world how delicate our window into the cosmos truly is. Across all of human history, only 3 interstellar objects have ever been detected: Oumuamua, Borisov, and now Atlas. 3 brief visitors from other suns, each offering a single fleeting encounter before vanishing forever into the dark. Missing even 1 hour of their behavior is not a minor loss. It is a wound that cannot be repaired. These objects carry chemical fingerprints of alien star systems, atoms forged in foreign stellar nurseries, dust grains shaped in temperatures our solar system never experienced, and isotopic patterns that reveal the architecture of distant planetary disks. To scientists, each interstellar comet is not merely a body of ice and rock, but a messenger, a rare chance to compare our cosmic chemistry to that of worlds we will never reach. From such messengers come models. Models of planetary formation beyond our sun, of interstellar radiation, and of dust evolution across galactic environments. Some interstellar objects may even carry complex organic molecules, frozen shards of prebiotic chemistry drifting through space, hinting at the conditions that may exist on unseen exoplanets. These possibilities are not luxuries. They form the foundation of modern astrobiology, and this is why the missing window mattered. Losing 12 to 36 hours of Atlas's behavior meant losing irreplaceable insight, a silence that no telescope, not even Webb, could ever revisit. The universe does not rewind. It moves, it passes, and it leaves us only the fragments we manage to catch. Atlas was no different, and what China's uninterrupted record revealed would challenge every assumption astronomers held. When China released its spectral dataset, scientists were stunned. The comet's coma, the gas cloud surrounding its nucleus, was dominated not by water, but by carbon dioxide. This inversion contradicted everything astronomers expected. Most comets brighten with water vapor as they approach the sun, the signature behavior of frozen bodies that form within our own solar system. But Atlas refused to behave like a native visitor. Its spectrum told a different story. CO2 outweighed H2O by a significant margin. That single detail upended its origin narrative. A carbon dioxide-dominated object suggests an environment of extreme cold, the type found not in ordinary comet belts, but at the outermost reaches of a foreign protoplanetary disk, regions colder and darker than even the Kuiper Belt. Places where water freezes so deeply that carbon dioxide becomes the primary volatile. This pointed to a birthplace shaped by conditions alien to our sun. Another star, another climate, another cosmic neighborhood altogether. And a deeper analysis added another layer of surprise. The dust grains embedded in the comet's tail were unusually large, heavy, and carbon-rich. Grains shaped not by gentle solar winds, but by harsher radiation or ancient thermal processing. Material unlike anything commonly seen in local comets. Atlas wasn't simply a visitor from another solar system, it appeared to be a visitor from another type of solar system, possibly the first of its class ever studied in detail. But extraordinary interpretations require extraordinary precision, and that is where China's data methods drew global attention. In astronomy, data is not trusted because it is impressive. It is trusted because it is calibrated. And China calibrated everything. The FITS files that appeared quietly on their archives were marked by an almost obsessive level of precision. Millisecond-level timestamps, exact world coordinate system metadata, and tri-filter photometry captured in B, V, and R bands. Every frame included the information needed to reproduce its measurement entirely. The photometric calibration was anchored to Landolt standard stars, a global benchmark of stability. These were cross-matched with the Sloan Digital Sky Survey and converted into the AB magnitude system used by Western observatories, eliminating any drift or mismatch in brightness scales. The spectra were calibrated against thorium, neon, and argon lamp lines, maintaining a residual wavelength error below 0.05 nanometers, tight enough to meet NASA and ESA scientific tolerances. The final step was the most critical: independent reproducibility. Teams in Hong Kong and Taiwan processed the same datasets using different software pipelines. Their results aligned almost perfectly. The brightness curves, positional drift, and spectral profiles matched within stated uncertainty bounds. The refined global orbital model achieved a precision of 0.2 arcseconds, allowing telescopes worldwide to reacquire Atlas using China's coordinates rather than their own. In astronomy, that level of accuracy is not merely competence, it is authority. And for many scientists, this moment marked an undeniable shift. The center of sky truth had temporarily moved, and the world could feel it. The blackout was a scientific event, but its implications drifted far beyond astronomy. Fast-moving objects cross an uneasy boundary where science meets military surveillance. Their paths resemble ballistic trajectories, hypersonic signatures, and orbital anomalies. Patterns monitored by the same global systems that track missiles, satellites, and classified spacecraft. That is why analysts inside Western intelligence circles reacted with unusual concern. A scientific blind spot had become an intelligence blind spot. For 36 hours, the United States could not independently track a fast-moving object entering and exiting solar glare, and that vulnerability echoed uncomfortably through defense briefings. In that moment, China demonstrated something subtle but historic. They had tracked a celestial object that the U.S. temporarily could not. Not through satellites, not through deep space radar, but through a chain of ground-based observatories functioning in perfect continuity, while others paused. At its core, this moment revealed a shift in space situational awareness, the backbone of strategic security. Whoever sees the sky first controls the narrative. Whoever sees it continuously controls the truth. And for the first time in decades, that advantage momentarily left U.S. hands. The public never responds to silence with patience. They respond with imagination. And the gap of 36 hours triggered a surge of speculation across forums, social platforms, and amateur astronomy communities. Theories spread quickly. Claims that NASA had intentionally shut down telescopes, that China was hiding anomalies, that Atlas might be artificial, that the timing was coordinated, and that this was the first real US-China conflict in space. Most of these narratives were baseless, but the blackout created a vacuum, and the internet filled it. Mainstream media adopted a more cautious tone, yet their headlines still carried a quieter alarm. A rare and puzzling alignment of maintenance cycles, China emerging as the primary source of cosmic truth, and a widening imbalance in global scientific infrastructure. For many viewers, the story became painfully simple. China watched, NASA missed, and the world seemed different because of it. In astronomy, mirrors are more than technical instruments. They are symbols of scientific reach and national capability. The West controls most of the world's 6 to 10 meter telescopes, colossal machines on the summits of Hawaii, Chile, and the Canary Islands. China, by contrast, relies on a distributed network of mid-sized telescopes, smaller but more numerous, automated, and relentless in duty cycle. And for fast-moving objects, continuity outweighs raw size. A single giant mirror can see deeper, but only when it is awake. A synchronized network of smaller telescopes can see further. During Atlas's critical hours, that mattered more. China stacked hundreds of exposures, producing a co-added result that rivaled the signal-to-noise ratio of an 8-meter class Western telescope. It was a quiet demonstration of a larger truth. Aperture in geopolitics is not merely the width of a mirror, it is the width of participation. And participation in this event flowed decisively in one direction. The blackout was not a conspiracy, it was a consequence. The West's astronomical infrastructure has been weakening for years. Hubble is aging, its gyroscopes are decades old, its calibration downtimes are longer and more frequent. The James Webb Space Telescope, while powerful, is too complex to pivot quickly. Every instrument switch demands hours of thermal stabilization. Mid-sized observatories across the US and Europe, once the backbone of rapid response sky monitoring, have been shut down or defunded. And with the concentration of scientific power in a handful of megatelescopes, the system has become brilliant but fragile, oversubscribed, and vulnerable to synchronized maintenance. The blackout was not an accident. It was the inevitable outcome of a strained infrastructure, unable to respond to unexpected celestial events. There was only one true solution capable of preventing such a global blackout: polar observatories, especially in Antarctica. The South Pole offers continuous night, low atmospheric interference, and sunlight cycles that never align with mid-latitude observatories. China spent years quietly strengthening its Antarctic presence, expanding not only climate and geological research, but also astronomical capability. Meanwhile, the US and Europe hesitated, constrained by budgets, logistics, and caution. Atlas exposed this gap brutally. The nation with polar observatories holds the final uninterrupted window into the cosmos, and in this domain, China surged ahead. Then came the question that few wanted to speak publicly. During the 36 hours of solitary visibility, did Atlas behave unusually? Interstellar objects have a history of defying expectations. Oumuamua accelerated without visible jets, its motion resisting conventional gravitational models. Could Atlas have shown something similar while the world was looking elsewhere? We may have missed non-gravitational accelerations, jet-driven thrust signatures, rotation irregularities, or asymmetric outgassing, signals that exist only in real-time data, signals impossible to reconstruct once lost. The blackout may have hidden unknown physics, not through intention, not through neglect, but simply because the sky does not negotiate, it moves, and for those hours, we were not watching. This led to a wider philosophical debate. Who owns the data of a once-in-a-century interstellar visitor? Is it national property, a shared scientific commons, a strategic resource? Should maintenance schedules be overridden when such objects appear? Should the world establish a unified emergency response framework under the UN or the International Astronomical Union? Atlas revealed that we have no such system, no redundancy, no unified chain of custody, no guaranteed continuity. The global sky is monitored by a patchwork, and 3i Atlas tore that patchwork at the seams. When China ended its report with the words, "Nothing about the object has changed, yet everything has," it was more than poetic restraint. The comet had not changed. Its orbit, chemistry, and speed remained the same. What changed was humanity's understanding of who sees the universe first, who holds uninterrupted access to truth, and who commands the narrative when the world looks up. For 36 hours, the power balance of astronomy shifted. And in those 36 hours, a new reality emerged. Not because the object changed, but because the world did.